This video is on hydrates. So a hydrate is a compound with a specific number of water molecules bound to it. So I have a compound is ionic. So if this is my ionic compound, attached to it are water molecules. So it's like it's covered in water molecules. And that all together makes up my hydrate. Now the inside portion, this is called my anhydrous salt. This is the compound that remains after the water is driven or evaporated off of the hydrate. So the anhydrous salt is just the portion that gets left behind. When we write hydrates, we show that my anhydrous salt is bound to a distinct number of water molecules. To do this, we use a dot to connect the formula of the compound, which is usually ionic, to the number of water molecules. When we name it, we say the salt's name, which is our ionic compound, and then we say our hydrate portion, so the number of waters, and we use a prefix to tell our number of waters, and then we write hydrate. So for example, I have MgSO4. That's magnesium, magnesium sulfate, my ionic compound, which you've already learned how to name, and then my hydrate portion of it, well, the prefix for 7 is hepta. So I say hepta, and then it's a hydrate, so I say heptahydrate. Okay, so this portion is the new part. So the beginning part, same as before, then we just say heptahydrate. So that means that on every magnesium sulfate, there's 7 water molecules that are bound to it all the way around. When we calculate the total mass of the hydrate, we need to include the mass of the water molecules in addition to my ionic compound. So I have to add, it's the total mass of the anhydrous salt plus all my water molecules. That's a W. If I want to figure out the percent of water in a hydrate, just like before, I take my part out of the whole. My whole is my hydrate and my part is the water. So I take the mass of all the water molecules, divide that by the total mass of my hydrate, and it's a percent, so I multiply that times 100. Now these problems are usually done in the lab, and so you get lab data where we start with our hydrate and then we evaporate off the water molecules, and then what's left is our anhydrous salt. So if we look at our example problem, we have a 5-gram sample of a hydrate. So first I write that my hydrate has a mass of 5.00 grams. After heating, the dried barium chloride, no water molecules, has a mass of 4.26 grams. So the difference in these two is the amount of water that left my hydrate. So I want to calculate the percent of water in the hydrate. Well, first I need to know how much water was there. So the difference between these two numbers is my amount of water. So 5 minus my 4.26 is my 0.74 grams, and I like to write that this is the water. So hydrate minus the barium chloride gives me my water that evaporated away. So the percent of water is my water divided by my hydrate times 100. So my water is the 0.74 grams divided by my total mass of the hydrate, which was the 5.0 grams, times 100. And when I plug that in, I get 14.8. But I look 2 significant figures here, 3 here, so I can have 2 in my answer. So 15% water. Okay, that's the easy part. Now I can go ahead and I can apply what I've learned in empirical formulas and figure out the actual formula and name for my hydrate. So it's a ratio of 1 anhydrous salt, right? 1 anhydrous salt to some number of waters around it. So my empirical formula, I want to go grams to moles. So I take the grams of my anhydrous salt, so my 4.26 grams of barium chloride, and it's anhydrous salt to waters. I want to know that ratio between the two of my waters to my salt. So then my water, 0.74 grams of water. So first step, grams to moles. I take my grams, I drop them down, grams H2O, grams BaCl2, grams to 1 mole barium chloride, to 1 mole of water. And here, grams to moles, look back on my mole count, I have to use my molar mass. So the molar mass of barium chloride is 208.3, and of water is 18.0. So when I do that, I get relatively small numbers. I like to go at least 4 decimal places on these so I don't have rounding error. So when I do this, I get 0.0205 moles of barium chloride. And here I get 0.0411 moles of water. So I've got grams to moles. I divide by my small. My small is my barium chloride, so 0.0205. And when I do that, I get 1 mole of barium chloride for every 2 moles of water. Now I have a whole number ratio here, so I don't have to multiply till whole. They're already whole. So that means when I write my formula, I have barium chloride. I put my dot, 2 water molecules, 2 H2O. So I write the name, my first half, barium chloride. I have 2 waters, so it's dihydrate.